Welcome to clickmyproject.com. Let us see the title of the project. The title of the project is Dirichlet Process Mixer Model for Document Clustering with Feature Partition. Let us see the abstract of the project. The document clustering, grouping unlabeled text documents into meaningful clusters, is a substantial interest in many applications. At one assumption taken by the traditional document clustering approach is that the number of clusters K is known before the process of clustering. K is regarded as a predefined parameter determined by the users. However, in reality, determining the appropriate value of K is a difficult problem. First, given a set of documents, users have to browse the whole document collection in order to estimate the K. This is not only time consuming but also unrealistic, especially when dealing with a large document dataset. Furthermore, an improper estimation of K might easily mislead through the clustering process. Clustering accuracy degrades drastically if a bigger or a smaller number of clusters is used. Therefore, it is very useful if a document clustering approach could be designed relaxing the assumption of predefined K. So, the proposed system attempts to group the documents into an optimal number of clusters while the number of clusters is discovered automatically. The first contribution of the proposed system is to develop a Dirichlet process mixer model to partition the documents. The Dirichlet process mixer model has been related to the Bayesian. It shows the promising result for the clustering problem when the number of clusters is unknown. The basic idea of the proposed model is to jointly consider both the data likelihood and the clustering property of the Dirichlet process prior that data points are more likely to be related to the popular and large clusters. When a new data point arrives, it either rises from the existing cluster or starts a new cluster. The flexibility of the DPM model makes it particularly promising for the document clustering. However, there is a little work investigating DPM model for document clustering due to the high dimensional representation of the documents. The problem of the document clustering: each document is represented by a large amount of words, including discriminative words and non-discriminative words. Only discriminative words are useful for the grouping of documents. The involvement of the non-discriminative words confuses the clustering process and leads to poor clustering solution. When the number of clusters is unknown, the effect of non-discriminative words is aggregated. Proposed system addresses this issue and design a DPM model to tackle the problem of document clustering. A novel model, namely Dirichlet process model with feature partition, is investigated for the traditional DPM model by conducting feature partition. Words in document set are partitioned into two groups, in particular discriminative words and non-discriminative words. Each document is regarded as a mixture of two components. The first component, discriminative words, are regarded from the specific cluster to which document belongs. The second component, non-discriminative words, are regarded from a general background shared by all documents. Only the discriminative words are used to infer the latent cluster structure. Let us see the data flow diagram of the project. At first, we should start the program, then the dataset collection. Here, the dataset collection represents the collecting of the document dataset. Here, in the project, we should use the dataset as the document collection. So, we can use more number of document collection, and the document collection can be clustered according to their relationship. Then we should apply the pre-processing. The pre-processing is the first step in the data mining to perform the mining process in the dataset. So here we are going to use the document dataset. To get the more accuracy of the clusters, we should first perform the pre-processing. Here the two type of pre-processing is done. One is stop word removal and the another one is the stemming process. Here the stemming is performed first. The stemming removes the suffixes dis, ing, ed, likewise letters to produce the words in a general format. So then only we can get the more relationship between the words. Then the stop word removals. The stop words are the meaningless words. So we should first remove all the stop words also. Then the cluster structure determination. Here we should use the finer mixture model. To identify the words, we should first apply the distinct words generation. To find the distinct word generation, we should first determine the all words in the dataset collection. So we should create the words in the document dataset. To find the term frequency, we should just generate the distinct words. The first step is the generating all the words in the document collection should be created. Then we can easily identify the distinct words from the document all words collection. So after producing the distinct words, each term's frequency has been calculated. So the clusters are formulated according to these term frequencies. Finally, the clusters are produced. Here, to produce the clusters, we should use the variational inference algorithm. So the algorithm finds the optimal cluster. It helps to place the correct object in a correct cluster. The clusters produced automatically here. The number of clusters is initially unknown. So here the clusters are produced according to their term frequency automatically. Let us see the demo. And to log in, we should first enter the username and the password. After entering the username and password, we should click the login button. It will redirect to the next page. So here we should first generate the stemmed words. That is, we can generate stemming in the files. So to perform the stemming, we should give the input text file, and then by clicking the stemming button, the stemming is automatically performed. To give the input, we should click this button. So here in the dataset, we should click the one file. When we click the stemming button, the stemming is automatically performed. Then we should click the next button. Here the stop word removed is performed. So to perform the stop word removed, we should give the input as the stemmed files. So here the stemming applied files is created. Then we should choose that file, and the stemmed performed files are open. Then we should click the remove stop words. So here the stop word is removed. We can see the stop word removed files. Then we should click the next button. Here the stemming and stop word is performed as a whole. So the total collection of files and total collection of the stop words has been performed here. So to do that, here we should give the folder as an input. We should click the my computer. Here we should click the dataset as input to perform the stemming. So the number of files is 60. Here the stop word is performing. So we should give this stemming performed files as an input for the stop word removed files. Here we should click the browse files. We should open the stemmed files. Here the stop word removal is performed. Then we should click the next button. Here we are going to find the distinct words. Then only we can find the term frequency of these distinct words. So before that, we should generate all words in the files. So the files contents are as a whole. So to get the distinct words, we should split all the words and then generate the distinct words. So here we should give the stop word removed files as a input. So here stop word removed files folder has been given as the input. So it contains the stop word removed documents. When we click the retrieve button, the files has been shown. Then we should click the generate distinct words. So here after performed, it will be shown. Here the all words in the documents has been shown, and the distinct words from these all words has been generated in the right side. So when we click the next button, we can see the next form. Here the term frequency for the distinct words has to calculate. So to do that, first we should give the stop word removed files as an input. So here stop word removed files has been selected. Then we should click the OK. When we click retrieve, the folders are shown here. Then we click the show. The term frequency has to calculated. So when the term frequency is calculated, the success message has been shown. When we click OK, the terms frequency has been shown here. So in the left side, each word and the corresponding frequency is in the right side. When we click next, it will show the higher frequency and lower frequency removal. Here it is also a one type of pre-processing. So the higher frequency and lower frequency words did not get any impact on the cluster structure. So only we are removing this higher frequency and lower frequency words. When we click show, the normal frequency and terms are shown here. When we click remove, we can get the success message. So the higher frequency and lower frequency words are removed here. Then we click the OK. Here the pre-processed content has been shown. Then we should click the next button. Here the clusters has been formulated. Then the clusters are shown here. For example, we should click the cluster and the corresponding words in that cluster is shown here. Then when we click that word, the corresponding documents has been shown here. Then when we click a document, the document contents has been shown here. Then we should click the graph button. We can see the graph. The chart represents the time to form the clusters corresponding to the number of the documents. In the y-axis, this time is shown, and in the x-axis the number of documents has been shown. Thank you.